Welcome once again to the today's session. We have been discussing about activated sludge process. So we solved few numericals as well. Let us solve few more numericals so that you can expose to wide varieties of problems. 100% you can expect one question in GATE exam, 100%. Not only GATE exam, even it is very important for ESE exam as well. Without calculator also, few of the concepts, few of the parameters you can work out without calculator. Therefore, this topic is very, very important both for GATE and ESE exam. So before we start this topic, so go through this. So Unacademy, GATE, an exam-like experience for GATE and ESE, January 8, 15, 22, 29. So they are providing all India rank to you. Enroll for free. Contact that number displayed there. So let us try one more numerical, different kind of numerical related to ASP. Good numerical. Come on, work out. This is ESE question. Options are given, of course, but I am not writing there. Options are given there, but I did not give you options. Work out. So what is given to you is Q is given. 50 into 10 power 6 liters per day. I can convert this into MLD, 50 MLD. And YI value is given, influent BOD. And organic loading rate or volumetric loading rate is given as 540 grams per cubic meter per day. So I'll convert this into kilograms. So kilogram per meter cube per day. So that it become easy for us to calculate. So what is volumetric loading rate expression? Q into YI by V. I told you to substitute Q in MLD, this in milligram per liter, this in meter cube, so that we'll get answer in kilogram per meter cube per day. So this side also given kilogram per meter cube per day, 50 MLD, 180 by V. This is also kilogram per meter cube per day converted now. This side also kilogram per meter cube per day. So from this we can calculate volume of aeration tank. Just with unit system we can adjusting it, you can find it out. Can't work out. Work out the value. This is the answer. Very good. Next, let us try one more question. This is also ESE question. Here is given L per day. L per day means liters per day only. Can't work out this question. This is easier than last question. By 1000 if we divide, you will get 2 meter cube per day. So YI is given as 180 milligram per liter and X is given as 1800 milligram per liter and FIM is given as 0.5 day inverse and we have been asked to find out V. So the one thing which we need to notice is, so two parameters, you can take them as 0 freely as and when not given in the question. One is YE, other one is XE. If YE and XE are not given, if required, when YE and XE are not given, otherwise YE and XE are not given, if required, they are taken as 0. So normally effluent supposed to contain any BOD, but If something is there in effluent, they will give you. If nothing is there means we assume it as 0. So all microorganisms should settle down in the secondary clarifier. They are supposed to settle down, but practically it is not possible. Some organisms escape. If they escape, Xe will be given. If they all of them settle down, Xe becomes 0. That's the meaning. If Xe, Y is not given means there is no POD in the effluent, there is no MLSS in effluent. Understood? If required, you can take them as 0 comfortably. Without any second thought, you can take it as 0. Understood? So therefore, so in this question, what we require, F by M is equal to Q into yi minus ye by v into x. So since y is not given, therefore we take y is equal to 0. Then y becomes 0. 0.5 is equal to, it is 50,000 into 180 minus 0 by volume is unknown, x is given as 1800. Therefore, volume of aeration tank is equal to, come on, work out. To drive you that point, this question I took. So whenever X and Y is not given, you are free to take X and Y as 0 if required. Exactly 10,000 meter cube. Very good. So this you can learn more and more by solving more and more numericals. Let me take one more numerical before we close this topic. Okay? This is also ESE question. The MLSS concentration in aeration tank is 2000 milligram per liter, and sludge volume after 30 minutes settling is settling in 1000 ml graduated cylinder is 176 ml. Then sludge volume index is, so what is given? We put that 1 liter sewage sample into graduated measuring cylinder. So solid settled and occupied a space of how much? 176 ml. This is given as 176 ml. So 1 liter sewage sample with MLSS 2000 milligram per liter. Settling 176 ml. Therefore, sludge volume index. What is sludge volume index? Space occupied in ml by MLSS. Okay, space occupied is 176. MLSS you substitute in grams. So 2000 milligrams means, milligram per liter means how many grams? So 2 grams per liter. So 2 grams. Therefore sludge volume index is 176 by 2. It is 88 gram per ml. 88 ml per gram. Sorry. That was the answer for this question. That's how you can calculate. Here now, comfortable? How to written formulas? I forget, sir. How to written formula means what? You have to see the diagram. That's why diagram is important. From the diagram only we derived all these things. Right? From the diagram only we derived. That's why practice is required. Ankit Kumar. All India level exam this is. How to retain formula means what? You have to understand the concept. So, before settling it is X. After settling it becomes XU. So what amount of space it occupied? 176. 176 to what is sludge volume index definition? Space occupied in ml by 1 gram of MLSS after settling for 30 minutes. Right? That's called sludge volume index. So 1 gram occupy how much space? So here how many grams? 2 grams. 2 grams occupy 176 ml space. 1 gram occupy how much space? 176 by 2. Understood? So that's why practice is required. Practice makes man perfect. Okay, next one more. For your comfort and convenient, let us solve one more question. GATE 2003, this is. So, you know, this question is very popular, sludge volume index. Settling test on a sample drawn from, that is sewage sample. Aeration tank. There is 1 liter sample taken from aeration tank. Aeration tank of ASP. MLSS is equal to 2800 milligram per liter was carried out with a 1 liter sample. The test yielded settled volume of, what is the settled volume? Space occupied. Space occupied by the solids, 200 ml. The value of 200 ml, sorry, the value of sludge volume index shall be, he has given options 14, B 7, 34.2, C 71.4, D 271. So 4 options are given. Come on, work out. Here space occupied is how much? 200 ml. MLSS concentration is 2800 milligram per liter. That means how many grams in 1 liter? 2 grams in 1 liter. So 2 grams occupy 2.8 grams occupy 200 ml space. 1 gram occupy how much space? That's called sludge volume index. Space occupied by X. This is X. So 200 ml space, 2.8 grams. 1 gram occupy how much space? So it is ml per gram. 200 by 2.8. That was the answer. Any difficulty? And Anil Kumar, if you understand the concept, no difficulty. 200 by 2.8, 71.4 ml per gram. So options, which option is matching? C is matching. So like that your tick mark. Comfortable now? Activated sludge process. So 3 questions we solved before break, first session. Now 4 more questions we have solved. So if you practice them, you will become perfect. Okay? Hope it is sufficient for you. Next, let us go to trickling filters. Shall we go to trickling filters? So trickling filters works on the principle of attached growth process. Attached growth process. So in this process, microorganisms are attached to inert media as a biofilms. So like a conventional type of offering food. So they occupy, all organisms occupy at one space, food passes through them. So they enjoy the food. That means we serve the food to them. We ask them to rest at one place, we serve the food. That is, food chase microorganisms. Microorganisms attached to inert media. Inert media in the form of biofilms. Biofilm means what? A film, a layer carrying microorganisms. Biofilm. Biofilms are attached to the inert media. So that is, in this process, food chase microorganisms and wastewater pass through biofilms. That is, food chase organisms. So organisms are at one place, food is going to organisms, asking the organisms to enjoy the food. It go and offer on its own. Okay, it take rest at one place. Like how Zomato, Swiggy and all serving food to you. You just order and sit at home. Food will come to your home. Exactly like that. But whereas earlier what we used to do, we used to find out a nice restaurant, going, taking a car or bike or something like that, traveling all the way, reaching there and eating food. But nowadays, sit at home happily. They'll serve you food. Like Zomato restaurant, Zomato, Swiggy and all there. Nowadays, they serve food to your home. So now things have become so simple and so easy. Understood? Ankit Kumar. Okay? This is about attached growth process. Why it's called attached growth process? Microorganisms attached to the inert media as biofilms. They are static, they are stable at one place. They remain at one place and food passes through them. Food will be moving from place to place and asking the biofilm to enjoy it. Okay? That's it. So trickling filter consists of a bed of highly permeable media. Okay? Trickling filter is nothing but a trickling filter consists a bed of highly permeable media to which microorganisms are attached as biofilms through which wastewater trickle down. That's all. That's why it's called trickling filter. Understood? So it is circular tank it is. So it consists a circular tank randomly packed with broken bricks or broken stones. Broken bricks or broken stones are used as a inert media. On the surface of the broken bricks or broken stone, we grow microorganisms as a biofilm. Microorganisms firmly held to the inert media as biofilm. They stick to the inert media. It consists a circular. It consists a circular cylindrical tank randomly packed with broken bricks or broken stones. (25 mm to 100 mm) as inert media. That's all. Nothing will be there. Simple arrangement. It is. If you see trickling filter cross section, you will find like this. So we apply wastewater. Okay. So we apply wastewater here from center. So it will be like this. So here, this is packed with stones. Broken bricks or broken stones at its bottom. You will find small drainage system also. This is drainage. So stones or bricks are filled here in this space. Broken bricks or broken stones. Okay. So this is attached to string like this. And here this is honeycomb. See here oxygen is circulated. We see that there is a free circulation of oxygen throughout this. Air circulation, air contain oxygen only. So aerobic process now this is. So this is here wastewater is applied, influent is applied, Q in here. Right? Effluent is collected from under drainage system. So here this contain small nozzles through which we apply wastewater at the top of the media. So wastewater trickle down like this. This is wastewater. So on the surface of the media, if you see, and if you see this, there is a broken brick or broken stone. This is inert media. Broken brick or stone. This is used as inert media. On the surface of the inert media, what happens? Microorganisms grow. Microorganisms grow on the surface. These are the microorganisms. They grow as a biofilms. A layer of microorganism flourish on the top of the media like this. Right? This is called biofilm. So wastewater passes through this biofilm. So it is moving like this. Sheet of wastewater carrying food. Right? Food is there in this. This is wastewater flow. So this will be passing through this. So this is carrying food and organisms are exposed to food and oxygen. Okay? That is how it happens. Understood now? So what you need to know is how to design this trickling filter. Okay? This is cross section of trickling filter. Clear or not? This is Ankit Kumar. So, in the beginning if you see, the thickness of biofilm will be very, very less. As time progresses, thickness of biofilm increases. So this inert media on the surface, you see, in the beginning thickness will be very less. As time progresses, what happens? Food is available, oxygen is available, so biofilm start growing. At time t1, you see, thickness increases like this. As time t1, t2, as time progresses, what happens? Thickness of biofilm keep on increases. At one stage, what happens? The organism close to inert media, they neither get food nor get oxygen. So then what happens? They are pushed into death phase. Oxygen is not available. So organisms there neither get food nor get oxygen. So they are pushed into endogenous decay phase, death phase of their life. Okay? Then, so once organisms close to inert media die, what happens? That clinging mechanism weakens. When clinging mechanism weakens, biofilms are sheared off. So, when biofilms are sheared off, what happens? So, that old biofilm is move along with wastewater, and new biofilms start flourishing on the top of the media. So that process is called sloughing. So as thickness increases, biofilms are sloughed off. Sloughed off means as thickness of biofilm increases, because growth, microorganisms grow more and more number. As food is available, oxygen is available. As thickness of biofilm increases, then at one stage biofilms are sloughed off. Increases, then they are sloughed off. Sloughed means they are removed. Biofilms attached to the media, they are detached. Then they are sloughed off. The sloughing definition they are asking. Sloughed off means, what is sloughing? Detachment of attached biofilms. Detachment of attached biofilms from inert surface is called sloughing. This question also they are asking theory question in competitive exams. Remember, okay? Then we'll see the design part of trickling filters. Is it okay? Cutoff. What cutoff? Angit Kumar. What is cutoff? Not cutoff. Slough off. Sloughed off. Detachment. Detachment of attached biofilm from inert surface is known as sloughing. Not cutoff. Not cutting. It is sheared off. Sheared off. Sheared. Cutting is different. Shearing is different. Okay? Next. Let us see the design of trickling filters. Our interest is numericals for GATE exam. Trickling filter design is based on NRC equation, NRC of USA equation. This is a very popular method of designing this trickling filter. So NRC of USA, NRC means National Research Council of United States of America. NRC of USA equation is an empirical formula. NRC has proposed that formula. Is an empirical formula used to find BOD removal efficiency of trickling filter. So I'll write that equation. So BOD removal efficiency of trickling filter is equal to, it is 100 by 1 plus 0.0044 into root of Q into yi by V into F. So you have to remember formula, this is empirical formula, there is no shortcut for this. So if you understand the terms in this and couple of problems, numericals is all, you can remember this formula. Okay? BOD removal efficiency is equal to 100 by 1 plus 0.0044 into root of Q into yi by V into F. This is the formula. Okay? In this equation, if you see, terms are important. Q into yi by V. What is this? Already we know this. This is organic loading rate. Organic loading rate or BOD loading rate or volumetric loading rate. We saw this in activated sludge process. Okay? So it is expressed in kilograms per hectare per day. Kilograms per hectometer per day. Units are very, very important. Okay? Whichever unit system, empirical formula, no? Whichever unit system you are supposed to substitute, in that you told to substitute, in that unit system only you need to work out the things. Or in your own customer unit, you try to solve the problem. You don't get in proper unit system. Things we don't get in proper unit system. So it should be in kilograms per hectometer per day. So this Q into yi in this equation is known as total BOD applied to trickling filter. BOD means what? BOD represent what? Biodegradable organic matter. How much amount of biodegradable organic matter applied to trickling filter? Total BOD applied to trickling filter. Trickling filter in kilograms per day, this is. If this is in kilograms per day, then what is the other component here? V. What is V? Volume of trickling filter in hectometers. Volume of trickling filter in hectometer. Hectometer is unit for area into depth. Area into depth. Area is expressed in hectares. Depth is expressed in meters. Then you will get volume. Area into depth is equal to volume. Hectometer will get. Right? Area is equal to cross-section area of trickling filter. So normally depth of trickling filter, we assume we provide anywhere between 0.9 meters to 2.5 meters. The best value being 1.8 meters. So depth is known to you, then what you can find out? Surface area of trickling filter. So surface area of trickling filter is equal to volume by depth. What is surface area? It is circular, no? It is circular in plan. So surface area is pi by 4 d square. Surface area of trickling filter is equal to volume by depth. So surface area of trickling filter, otherwise okay you can put, is equal to pi by 4 d square, which is equal to volume by depth. Then you can find out diameter of trickling filter required. So it may be as small as 3 meters, it may be as big as 60 meters also, depends. This you can find out. That is what is called design. Understood? Okay? Diameter of trickling filter you can find out. That is one thing. One more parameter is there in that equation. What is that parameter? F. That F parameter is known as recirculation factor. F is known as recirculation factor. So this recirculation factor we work out by using 1 plus R by I by 1 plus 0.1 R by I whole square. Using this equation you can work out recirculation factor. So in this equation again R by I is known as recirculation ratio. See, now so many things are there in this. So R by I means it is effluent recycled to influent applied. So in trickling filter, what is recycled? Sometimes we recycle effluent. Effluent recycled to influent applied is known as recycling ratio. Amount of effluent recycled to amount of influent applied is known as R by I. If effluent is not recycled, R value becomes 0, then R by I becomes 0, then F value becomes 1. Understood? Clear now? So, based on F value, trickling filters are classified into two categories. Classified into 1. Standard rate trickling filters. 2. High rate trickling filters. Okay, let us see standard rate trickling filters. For standard rate trickling filter, there is no recirculation. So no recirculation of effluent. Effluent is just disposed without recirculating back to process. Therefore, R is equal to 0, then R by I is equal to 0. Okay? Then R by I is equal to 0, then F is equal to 1. So for standard rate trickling filter, F is equal to 1. You have to remember that, very popular in competitive exams. So standard rate trickling filter, if you see, so it is something like this. There is no recirculation of effluent. Just we use trickling filter followed by secondary clarifier. That's it. So there is no recirculation of effluent. This is trickling filter, secondary clarifier. After that, it is disposed, plain. So influent is applied here and effluent is disposed of. Effluent to disposal. TF means trickling filter and SC means secondary clarifier. Why secondary clarifier is required for trickling filter? Those biofilms which are detached from the surface move along with the wastewater effluent. So there they are put into secondary clarifier. Their biofilms, they settle down as a sludge. Once they settle down as a sludge, and effluent is disposed of. Okay? This is our standard rate trickling filter. In case of high rate trickling filter, there is a recirculation of effluent. Effluent is recycled. Not the sludge. Effluent is recycled. Sludge is recycled where? In activated sludge process. Therefore, R is not 0, not equal to 0. R is greater than 0. So R is greater than 0. Therefore, R by I is greater than 0. Then F is equal to greater than 1. The advantage of F is equal to greater than 1, volume of high rate trickling filter is less. compared to standard rate trickling filter. Standard rate trickling filter, volume will be very, very high. You see, if we compare standard rate trickling filter with high rate trickling filter, its volume will be very, very less. Then what else is there? Recirculation also there. Instead of disposing effluent all back to nature, portion of the effluent recycle back to process. So this is effluent to disposal. This will go for disposal. So portion of this effluent recycle back to process and added with influent. So how much is recycled back? R amount. So what is influent here? Q. Q is equal to I. This is influent. Influent is nothing but flow rate only. Q is equal to I. So this is trickling filter, secondary clarifier. So the advantage of recirculation is, so if you recirculate high strength waste, you are mixing with this is high strength waste. So this is after treatment, BOD becomes so low. So this BOD low strength waste joined with high strength waste, then strength is moderated. So that is how we can reduce the organic loading applied to trickling filter. When organic loading is required, volume also decreases. Therefore, volume of trickling filter inversely proportional to F. As F value increases, then volume decreases. That is the advantage of recirculation. Understood? Advantage of recirculation is volume of trickling filter will be less compared to standard trickling filter. So it consumes less space for installation. So this is how we can work out, we can understand what is the importance of recirculation. Clear now? Karan Kumar, Ankit Kumar. Okay then, let us solve some few questions. Then this is also connected with the normal efficiency formula. So efficiency of trickling filter is equal to, it is influent BOD minus effluent BOD by influent BOD into 100. This is equated to NRC equation. 100 by 1 plus 0.0044 into root of Q into Yi by V into F. So he will give you for a given influent, for a given effluent, what is the volume of trickling filter. For a given volume, right, for a given influent, what is the effluent produced by trickling filter. Like that questions they will ask. See what answer. For a given Yi, what is volume? For a given volume with a given influent BOD, what is the effluent produced by trickling filter? Like that questions they will ask. You can answer no? By linking these two formulae, you can answer comfortably. Clear now? So small topic this is, very small topic. Let us try few questions. Okay? GATE kind of questions. Are you ready to solve problems? Once again, check out that formula. So, unfortunately, you forced to remember, there is no option left with you. This formula you have to remember. And then, these terms, meaning of those terms. What is the significance of F value? What is recirculation? What is R? What is I? This idea is there, you can answer. Shall we take numericals? Shall we proceed with problems? Let us try this problem. He has given options: A 43.35 milligram per liter, B 23.3 milligram per liter, C 126.7 milligram per liter, D none. I think this is competitive exam question only. Come on, work out. What is the answer? No answer. What happened? What is given to you? Organic loading rate is given. Simply we can write it as OLR, which is equal to Q into Y by V. This is given in which unit system? 0.175 kilogram per meter cube per day. But it should be substituted in hectometer per day. So Q into YI by V is equal to 0.175 into 10 power 4 kilogram per hectometer per day. Listen now, 1 hectometer is equal to 10 power 4 meter square into meter cube. Therefore 1 meter cube is equal to 1 by 10 power 4 hectometer. This is there in denominator. So denominator of denominator goes to numerator. So therefore 10 power 4 I multiplied in the top, because hectometer is there in denominator. So 1 by 10 power 4 if you multiply, no, meter cube is there in denominator. 1 meter cube is equal to 1 by 10 power 4. Therefore 10 power 4 go to top. Now it is simple. You have been asked to find out what? Effluent BOD. So therefore, what is efficiency formula? So since nothing mentioned regarding recirculation, so it is designed as standard rate. Okay? Therefore, efficiency BOD removal is YI minus YE by YI into 100, which is also equal to 100 by 1 plus 0044 into root of Q into Y by V into F. So this whole thing is known to you. YI is known to you. Can't you work out YE? Come on, work out. YI is given as 150. So this is known. Only unknown is YE. You can find out. Come on, Ankit Kumar, Karan Kumar, work out. So 150 minus YE by 150 into 100 is equal to 100 by 1 plus 0.0044 into root of 0.175 into 10 power 4. Q into YI by V value, F is 1. That's all. Therefore 100 get cancelled. Then find out YE. The only unknown is YE. Come on, work out. Calculator is allowed in GATE exam. Comfortably you can work out. The IAS question means IAS exam, this question they don't ask, because without calculator you can't find out. Oh, 23.3 you got, very good. That option is there? I'm blindly believing you. So in that option 23.3 is a yes. Correct. You are right. Ankit Kumar. Good, very good. Try one more. Okay? From primary settling tank, sewage close to a standard rate trickling filter. At a rate of 6 mld, having a 5-day BOD of 150 milligram per liter. Find 1. Depth, diameter and volume of trickling filter. Adopting surface loading rate of 2500 liters per meter square per day and organic loading of 175 gram per meter cube per day. Okay? Then second question is efficiency of the trickling filter. Using NRC equation, of course, that is only popular. And third part of this question is the BOD of effluent. What is BOD of effluent? YE. So three things have been asked, you are expected to work out. So how many things you are expected to find out? Depth of trickling filter, diameter of trickling filter, volume of trickling filter. So what is given to you? Surface loading rate is given, organic loading rate is given. Surface loading rate is given as 2500 liters per meter square per day. Organic loading rate is 175 gram per meter cube per day. This is given. Next, efficiency of trickling filter. Third one is effluent BOD. Come work out using that data. Using this data, it will work out. So Q value also given to you. Q is given as 6 mld, YI is given as 150 milligram per liter. That's all. So as I told you, whenever you get surface area, surface loading rate, you can find out surface area. So surface area of trickling filter is equal to It is, how to find out surface area? Q by surface loading rate. So surface area is equal to pi by 4 d square, which is equal to 6 into 10 power 6 by 2500. So liters per day by liters per meter square per day. Come on, how much it is? So 6 into 10 power 6 by 2500. So it is 2400 meter square. So from this you can find out diameter of trickling filter. So diameter of trickling filter is equal to, I can write TF, right? Now to find out diameter, so 2400 into 4 by pi. Pi under root. That's it. You can find out diameter. Or what is diameter? So 2400 into 4 by pi root 55.27. 279 means 28. You can round it to 28. So 55.28 meters diameter trickling filter you have to construct. Standard rate means, see now, large space is required. Understood? Second one, depth of trickling filter. So next, organic loading rate is given. So organic loading rate is nothing but Q into Yi by V. So this is given as 175 grams per meter cube per day. This will convert into kilograms. 175 into 10 power minus 3 kilogram per meter cube per day. Okay. So I'll substitute Q in MLD. This is 6 MLD. Yi is given as 150. This is V. So this MLD into milligram per liter. This is also kilogram per day. Assuming that volume in meter cube, which is equal to 175 into 10 power minus 3 kilogram per meter cube per day. So right hand side, left hand side, units are same, you can equate. So therefore volume of trickling filter is equal to, it is 6 into 150 by 175 into 10 power minus 3. Straight away will get answer in meter cube. So 6 into 150 by 175 into 10 minus 3. Grams into kilograms. So it is 5142.85 meter cube. So this is also answer for one of the questions. Then depth of trickling filter is equal to is volume by surface area. So volume is 5142.85. Surface area is 2400 meters square. So meter cube by meter square you will get volume depth in meters. So depth of trickling filter is in meters. By 2400 if you take, it is 2.14 meters. So diameter, depth we worked out. That's what is called design. In addition to that, what else have been expected to calculate? These three things we worked out. depth we got, diameter we got, volume we got, efficiency and YE. Efficiency can work out by using NRC equation. So to work out in NRC equation, Q into YI product should be in kilograms per hectometer per day. But this is given 175 gram per meter cube per day. How to convert gram per meter cube per day into kilogram per hectometer per day? This is given 175 grams per meter cube per day. You multiply with 10 power minus 3, this become kilogram per meter cube per day. And once again multiply with 10 power 4, then this become kilograms per hectometer per day. So it is 175 into 10 power minus 3 into 10 power 4 kilograms per hectometer per day. So converted, and F is equal to 1 since standard rate trickling filter mentioned in the question. Therefore efficiency is equal to, it is 100 by 1 plus 0.0044 into root of Q into YI by V into F. Q into YI by V value we got already. 1 plus 0.0044. Q into YI by V value is 175 into 10 power minus 3 into 10 power 4. F value is 1. Simplify, we will get efficiency. Come on, I need efficiency value. Work out. What is your efficiency? So 175 into 10x power minus 3 into 10 power 4. Under root into 0.0044 plus 1 inverse 1 by x into 100. So I got 84.45. Okay, this is answer for one of the questions. Next, effluent BOD. So once you get this, can't you work out effluent BOD? Comfortably. So efficiency also equal to YI minus YE by YI into 100. So this we got 84.45. This is 150. YE is unknown. YI is 150 into 100. Therefore, effluent BOD is equal to, again we got 23.3 milligram per liter. That was the answer for. So this is how you are expected to work out questions using trickling filter with the help of NRC equation. Okay, let us go ahead with the next question. With this question we will close trickling filters. Example 3. Just to give practice to you. There is a question. Come on, work out. Come on, work out. First identify high rate trickling filter or standard rate trickling filter. Come on, this type of challenging questions you have to solve. Okay, what is given? Since recirculation is given, it is an high rate, it is a high rate trickling filter. So what is given to you? BOD of effluent is 20 milligram per liter. BOD of influent is given as 120 milligram per liter. Q is given as 2200 meter cube per day. Recirculation is given as 4000 meter cube per day. And I is nothing but Q, 2200 meter cube per day. So first what you need to work out? R by I ratio. Now work out 4000 by 2200. is 1.818. So f is equal to 1 plus r by I by 1 plus 0.1 r by I whole square. Okay, so 1 plus 1.818 by 1 plus 0.1 into 1.818 whole square. Can I work out this value? So it is 2.01. So then you can apply efficiency formula. Yi is given, Yi is given. But efficiency is equal to V into F. What have been asked to find out? Volume of trickling filter. Just volume. Okay. So this volume we require. So Q into II. So I'll substitute Q 2.2 mld into II is 120. How to convert liters into mld? Okay, into 120. So ml into milligram per liter will give answer in kilogram per day. This product will give answer in kilogram per day, assuming volume in hectometer. So we can substitute now. So it is already we got efficiency 83.33 is equal to 100 by Q into II is 2.2 into 120 by volume in hectometer. F value we got already 2.01. So from this you can find out volume of trickling filter. High rate trickling filter is equal to work out volume. You will get volume in which unit system? Hectometer you will get. Then you can convert whichever unit system you like. And simplify carefully this. What you got? Volume. Oh, very good. You will get answer in hectometers. Okay? Then you can convert whichever system you like afterwards. This is how you can work out. In this question, you are restricted only to find out volume, so let us work out that much only. Beyond that, not required. So, any question from any book you can work out if you are thorough with your concept. So, this is about trickling filters, very small topic it is. Okay? There are some operational problems also associated with trickling filter. One is called Psychoda problem. This is also a very popular question in competitive exams. Second one is ponding problem. So Psychoda problem is fly nuisance. Ponding problem, odor nuisance. So Psychoda is something like a small fly, like mosquitoes. They don't bite you, but they irritate you. They get into your nose, they get into your eyes, they get into your everywhere you will find them. Wherever trickling filter is there, they automatically flourish. They don't bite like mosquitoes, but they irritate you. So Psychoda flourish wherever trickling filters we use. Second problem is ponding problem. When thickness of biofilm so increases, resistance to flow also increases. So more water, more influent gets stagnated on the top of the trickling filter. When more influent gets stagnated on the top of the trickling filter, what happens? Then it start decomposing there only. That start releasing bad smell. So that indicates that trickling filter is influent is not passing through medium. So then what you need to do immediately, you have to stop applying the flow. So you have to rake the medium, lose the medium by raking and all, or otherwise the biofilm thickness somehow you have to decrease by adding some chlorine you have to add, so you can kill some microorganisms. Therefore you can control the growth. Biofilm thickness so fast it doesn't increase. So that's how you can address the problems. But both of the problems, the Psychoda problem, there is no solution for that, and over and above it require huge space to installation trickling filters compared to activated sludge process system. So nowadays they are almost outdated. Nowadays secondary treatment means it is only activated sludge process. And one more thing is that either you employ activated sludge process or trickling filters. Common thing in both of the thing is secondary clarifier. Secondary clarifier is common thing in both. In both trickling filter and as well as activated sludge process system. Secondary clarifier remove biological flux. That is microorganisms. From wastewater effluents prior to disposal. So their design is slightly different from normal settling tanks. So secondary clarifiers are designed based on solids flux rate. This question asked in GATE exam. Solids flux rate, normally this is expressed the what amount of solid settling down in a given time per unit surface area of that secondary clarifier. Okay, like surface, not surface loading rate exactly. Surface loading rate we use. Primary clarifier designed for surface loading rate, and sedimentation tanks we use in water treatment also, they are designed for surface loading rate. But secondary clarifier is designed for solids flux rate. So using solids flux rate, you can find out surface area of secondary clarifier. Which is equal to total solids to be removed by settled down by solids flux rate. At what rate they settle down? So total solid settled down is nothing but Q into concentration of solids. What is solids? MLSS. Mixed liquor suspended solids. MLSS means MLSS, otherwise some solids, by solids flux rate. See the units will get. Normally solids flux rate they will give kilograms per meter square per day. Okay? And this is Q, substitute in MLD into concentration milligram per liter, and this also become kilogram per day. This product become kilogram per day. So this kilogram per day will go off, left with meter square. That's how we can design. Once surface area is known, then with the rectangular tank it is L into B. With the circular tank it is pi by 4 d square. You can find out whatever you require. This for rectangular sedimentation tank, this is circular sedimentation tanks. Okay? You can find out that's what is called design of secondary clarifier. Understood? So we started with the primary treatment, then we saw secondary treatment. So influent we collect from town or city, put into treatment. First we employ screens, followed by grit chamber, followed by skimming tank, followed by primary clarifier, followed by aeration tank or trickling filter, any one, not both of them, followed by secondary clarifier. Then we dispose effluent. I don't have space here. So influent which we get from community, put into treatment. First one is screen, second is grit chamber, third is skimming tank, fourth is primary clarifier, next is secondary treatment, aeration tank or trickling filter, any one. If it is actuator sludge process, aeration tank. If it is Trickling filters different, secondary clarifier. Then we get effluent. This effluent to disposal. It will go for disposal. This is what is called municipal wastewater treatment. Throughout world, municipal waste, domestic waste is treated in the same fashion. Throughout world, India to America, everywhere domestic waste treated in the same fashion, because the kind of bad things present in domestic waste is biodegradable organic matter that is dealt in the same fashion everywhere. But if you see this, we get sludges from two places. One is from primary clarifier, second one is secondary clarifier. So the sludge which we get from primary clarifier and secondary clarifier, we treat and we dispose. That sludge also dangerous. Now whatever bad things are there in liquids, sewage that is settled in the form of sludge. Therefore, the sludge also properly we need to deal. And luckily, the nature of this both sludges which we get from primary clarifier and secondary clarifier is same. Therefore, they are dealt in same fashion. This is sludge. This is also sludge. Sludge from primary treatment, sludge from secondary treatment, collected, treated together and then disposed. So this is called sludge treatment. So sludge is also thoroughly treated prior to disposal. Then sludge also disposed. Treated sludge, we dispose. That's all. This is complete municipal wastewater treatment system. Municipal sewage treatment plant. STP people call. Treatment plant process flow diagram. Okay, how, in what sequence we treat. Okay, just have idea. So the next topic is what? Sludge treatment. अक्षरदीप, नमस्कार नमस्कार अक्षरदीप, प्रणाम प्रणाम, आपको भी प्रणाम। मैं बहुत छोटा आदमी हूँ, आपको भी प्रणाम अक्षरदीप। So this is complete. We also get sludge from grit chamber, but that sludge is not dangerous. That can comfortably dispose of. This sludge is not so dangerous. The sludge from primary clarifier, secondary clarifier is dangerous because it contains biodegradable matter, biodegradable organic matter. So it doesn't contain biodegrade. It is non-biodegradable. Therefore, comfortably you can dispose sludge from grit chamber. But these sludges you can't dispose. After treatment, you have to dispose. Understood? After treatment, comfortably you can dispose. Okay then, let us see the sludge treatment. How sludges are treated. Without wasting time, from sludge treatment also they are frequently asking questions in GATE exam. Akshadeep, are you from which place? You can't express my happiness after seeing you, sir. I have become old, Akshadeep, you can see me. So white beard, now I have become very very old. So that's why I lost my job. Now somehow I joined in Unacademy. So to help student community, whatever I could, I can help them. Okay. Come on, let us learn about sludge treatment as well. Ready? Are you ready for sludge treatment? Ankit, Akshat. So sludge obtained from primary clarifier and secondary clarifier is dangerous. Sludge collected from primary clarifier and secondary clarifier made inert. Made inert means made safe prior to disposal by applying sludge treatment. Okay? It is very, very dangerous. That's why it badly needs treatment prior to disposal. Oh, Akshatdeep, you are from Chhattisgarh? Okay. How are you doing? Nice to see you back after a long time. So sludge treatment is little complex process. Let us, before we talk about sludge treatment, let us see the composition of the sludge. Little idea should be there regarding composition of sludge. So sludge is a mixture of, sludge is composed of solids and water. Okay? Solids plus water. That is not known as sludge. Still, water is there in sludge, but not like wastewater, but little water content, okay, wastewater is more of water, less of solids, but here solids also reasonable amount is there. Okay, so solids content of the sludge normally range anywhere between 0.25%, it is as low as 0.2% and as high as 12%. And water content of sludge is remaining. It is 88% to 99.75%. So water content also called moisture content of sludge. MC, people call MC, moisture content of sludge. So we see the, understood? This point, sludge is more of water, solids also there, but it is more of water. So because of that, it is volume is very bulk volume of sludge we get. Disposal is very, very tough. Therefore, to make things simple and easy, if you apply treatment, then we reduce volume of the sludge and we also remove all bad thing present in the sludge, so that disposal becomes so simple and so easy for us. Okay? Remember, this is also they are asking questions in competitive exams. If you see the sludge family tree, so you will understand why it is dangerous. The reason why it is dangerous is because of solids. So this contain solids and remaining is water. Again these solids, two types of solids you can notice. One is volatile solids. So volatile solids are very dangerous. So 70% of solids are volatile, very dangerous solids. So they contain biodegradable matter. Remaining are non-volatile solids. Non-volatile solids content is very less, only 30% is about. So solids content is 0.25 to 12%. Out of that, majority of the solids are volatile. That's why it is dangerous. Okay. So in sludge treatment, what we do? We destroy this volatile matter. We try to reduce water content. Therefore, comfortably we can dispose after reducing the water content, after destroying the completely volatile matter. So we achieve two things by sludge treatment. One is volume reduction, the other one is strength reduction. So two things we carry out. One is volume reduction, the other one is strength reduction. Okay. Clear? So the object of sludge treatment is, sludge treatment is aimed to achieve one, volume reduction of the sludge. 2. Strength reduction of the sludge. Strength reduction means destroying the volatiles. Volume reduction occurs by reducing the moisture content. Okay? Sludge treatment is main purpose is two things. One is volume reduction. Huge quantities we convert into small amount. Disposal becomes so simple and so easy. Okay? Huge amount of sludge we convert into smooth. This room full of sludge finally become a drop after sludge treatment. And that drop also you can't dispose if it contains biodegradable matter. Therefore, that biodegradable matter present in the form of volatile solids, that also to be destroyed completely prior to disposal. Understood? Okay? So this volume and strength reduction of the sludges we achieve by employing 4 technologies. Volume and strength reduction of the sludge is achieved by employing the following. So 4 technologies we apply to get rid of the bad things present in the sludge and as well as to remove moisture content of the sludge. One is called sludge thickening, followed by sludge digestion, followed by sludge conditioning, and sludge dewatering and drying. So these 4 technologies we apply so that we can achieve volume reduction and strength reduction. Okay? So we'll see the numericals tomorrow related to sludge treatment. One session it will take because so many numericals are there. Important also for exam point of view. Then we'll start a new topic also tomorrow. Tomorrow also I'll take 2 sessions. Session 1 I'll take possibly from 4 to 6. And session 2 I'll take possibly from 8 to 10. 4 to 6, 8 to 10. Tomorrow also I will take. So today, right now, so at the last minute I don't want to teach the very important things to you. So before we conclude, so let us see. Some promotional content is there. So you can avail this mock exams, you can enroll for mock exams. All India level they are conducting and it is free of cost, and they will give you All India rank also. Okay? That too free of cost, avail it. So already December 4th and 8th completed. Again 4 more chances are there. January 8th, January 15th, January 22nd and January 29th again they are conducting. So you can enroll and write and find out where exactly you stand in the competition. Good night all of you. Shiva Ratri. Shiva Ratri. I am also trying to speak in Hindi. I'm learning slowly. So because I am not teaching in Hindi, so many students are not taking my class. Anyway, for a period of time, I learn, I speak. Of course, little I can speak, I can manage. थोड़ा बात कर सकता हूँ. उतना फ्लुएंट नहीं है जो फैकल्टी फ्रॉम नॉर्थ इंडिया. आई एम नॉट दैट फ्लुएंट इन हिंदी. उससे कंपेयर किया तो मेरा हिंदी थोड़ा कमजोर है, इसलिए मैं हिंदी में बोलने के लिए मेरे को डर आ रहा है. मैं डर रहा हूँ टू स्पीक विथ यू इन हिंदी. Especially Hindi market is good nowadays. Many North Indian students are writing GATE exam, so Hindi is compulsory nowadays. थोड़ा टाइम लगेगा मेरे को हिंदी में टीच करने के लिए। सो जब तक आई एम नॉट सो कॉन्फिडेंट ऑफ स्पीकिंग फ्लुएंटली, तब तक मेरे को थोड़ा दिक्कत है हिंदी में पढ़ाने के लिए। बट मगर मैं कोशिश करूँगा जरूर आपसे हिंदी में, आपको हिंदी में टीच करने के लिए मैं कोशिश करूँगा, जरूर करूँगा। नथिंग इज इम्पॉसिबल, एवरीथिंग इज पॉसिबल। Thank you. Again, we'll meet tomorrow. Tomorrow, possibly, I'll take 2 more sessions. Maybe I'll take 4:30. I'll try to take 2 sessions. Okay then, good night all of you. Thank you very much.